Hi folks, this is part 2 of lesson 4. So hopefully you give a quick thought as to how we might solve this problem. So it says using the results in 1, how might you determine the intervals where this function is positive and negative? Well, we're actually going to start with something similar to what we did with polynomials. Okay, and to start with a number line. Now the reason why I don't bother even working with a full Cartesian plane is that I only care about whether it's positive or negative. I don't care how positive or how negative it gets. So what I'm going to do is I'm just going to list all the places where this function might change sign. And what we saw is that it might change sign at x-intercepts and discontinuities. Okay? So first of all, we notice that this function is simplified, so we don't have to worry about any holes. So I notice here that the x-intercept is going to occur when the numerator is 0, so at x equals -1. And then I look at the denominator and I can see that the denominator is going to be equal to 0 at -3 and at 4. So this gives me all the possible places where the function might change sign. Okay, so let's list them here. So we've got -3, -1, and 4. Notice here I make no effort to really even put these in any to even space them out correctly, because I'm just interested in what's going on between these numbers. Now, why is it only what happens between these numbers? Because what did we say? These are the only places the function can change sign. That means that in this interval here between -3 and -1, it has to either be always positive or always negative, which means we only have to test one value in this interval to determine the sign of the whole interval. Okay? And this is what it's based on, is if we've evaluated that these are the only places the function can change sign, all I need to do is test one value in each interval to determine the sign in the whole interval. Okay, so some people make really big charts, and I think that's how the textbook does it, and you can certainly do that if you like. I try to keep it a little simpler, a little more efficient. So what I do here is I realize that the only thing that matters when determining the sign, okay, is the sign of the individual components. So that's the only thing I'm going to indicate here. So first of all, let me take any number less than -3. So let's say I take -4. Okay, and I'm going to put -4 into each of these terms and determine the sign. So here, if we have -4 plus 1, that's -3. So in the numerator, we have a negative, and then in the denominator, -4 plus 3, -1, still negative, and -4 minus 4 is -8, still negative. Okay, so what do we have? In the numerator, we have a negative number, and in the denominator, we have the product of two negative numbers, which is going to be positive. So negative over positive, there we go. In that interval, we know that all the y values have to be negative. As soon as one is negative, everything else has to be negative. Let's now go to this interval here. Let's pick a number between -3 and -1. So let's pick -2. And again, let's stick this into each of these components. -2 plus 1 is negative. Okay, -2 plus 3, that's a positive number. Okay, -2 minus 4 is negative. So what do we have? Still a negative number in the numerator, but in the denominator I have the product of a positive and negative number. So negative divided by negative, positive. So that means in this interval here, between -3 and -1, all the y values have to be positive. And we just keep going. Okay, let's pick a number between -1 and 4. Hey, 0 is the easiest one. 0 plus 1, positive. 0 plus 3, positive. 0 minus 4, negative. So in the end, what do we have? Positive divided by negative, negative. Let's do the last interval. Let's pick any number bigger than 4. Let's pick 5. 5 plus 1, positive. 5 plus 3, positive. 5 minus 4, positive. So in the end, I have a positive number divided by a positive number gives me something positive. So now what we can do is we can give the intervals where f is greater than 0, and we see that it's going to be between -3 and -1. Okay, I'll use interval notation here. Okay, and union with the other section where it's positive between 5 and positive infinity. Okay, notice I don't include any of the endpoints because I'm looking for strictly greater than 0. So even if there's an area where it's equal to 0, like at -1, I'm not looking to include that. And where is it negative? Again, I can just read it off my number line. So it's going to be less than 0. Here we see from -infinity to -3. And it's also going to be less than 0 between -1 and 4. And what this gives us now is a way, it takes a little more time than with polynomials. Polynomials, we could just draw a quick sketch. Okay, here a little bit more work, not too surprising given that the functions are more complicated, but this is essentially what you do, is once you have it in factored form and you've determined where the zeros and the vertical asymptotes are, you create a number line, and these locations at the asymptotes and at the 0 are the only places the function can change sign. So you just have to test one value in each interval to determine whether the whole interval is going to have positive or negative y values. So the next step now is to take everything we learned about rational functions, and we have enough information to draw reasonably good sketches for these functions. Okay, so that will be the next video.